Hello, today we're going to talk about comparing functions. All right, so basically what this comparing functions is, it's called direct variations, or I'm basically going to show you how to do slope, is all this is, but I'm going to go through some of the problems that are in here. So what you want to remember when you talk about direct variation or slope is this phrase right here, constant rate of change. That is very important because it means that you're staying at the same pace at all time, and what this makes is a linear function, a constant rate of change. You're always moving at the same rate. So if I'm saying this, if I start at 50 miles per hour, 5 hours later, if I stay at the constant rate of change, how fast am I going to be going? 50 miles an hour. Right? So if I say a computer company makes 30 computers in 2 hours, all right, and then they make, in 4 hours, they make 60 computers. How many are they gonna make in 6 hours? Right, so this is just a constant rate. So if I say, so how I would write this is, so for 30 computers in 2 hours is equal to 60 computers in 4 hours. All right. So if I simplify this down, I could simplify this down to 15 comps per hour equals, now give me 15 computers per hour. So at 3 hours, I'll have 45 computers done. At 5 hours, I'll have 75 computers done. And at 6 hours, I'll have 90 computers done. And that's what is called a constant rate of change. No matter what, you can tell what it's going to be after a certain amount of hours. I can tell you at 100 hours how many computers will be done because it's a constant rate of change. It's a direct variation. It's and how it's written in there is your y over your x, or your change in y over your change in x, or as it's mostly seen, y2 minus y1 over x2 minus x1. What that means is your final y value minus your initial y value, your final x value minus your final initial. This is just like the velocity formula, if you've seen that already. No, the acceleration formula. Just like the acceleration formula, if you've seen it already. All right, now for your first example. So I want to know what the direct variation is. If I say, all right, your y is equal to -3 and your x is equal to 2. What's your slope of your direct variation there? Woo, magical. All right, now for your second example. I put this one in a table. So your x's are 2 and 5, your y's are 4 and 8. So always give yourself a direction. I want to know what my direct variation is here. So how do I go from 4 to 8? Well, I add 4, of course. How do I go from 2 to 5? So I'm saying I'm going down. So that's +3. So then it's your y over your x. So you get 4 over 3. All right, the other way to do this is I take these two. So I'll do this one in green and I'll do it over here. So I'm gonna take my 2 points. So 2, 4, and 5, 8. All right, and I label them. So I'm gonna call that x. I'm gonna call this whole thing 1. I'm gonna call this whole thing 2. Label it xy, xy. Since this is my second one, I make those 2. Since this is my first one, I make those 1. And then I plug them into this formula over here. So my y2 is 8 minus my y1, which is 4, my x2 is 5, and my x1 is 2. So it gives me 4 over 3. 4 over 3, 4 over 3. That's 2 ways to do this. Example 3. Here we go. Oh my gosh, there's decimals. The world's gonna end. No, it's not. All right, you do this. I'm gonna do it this way. So I'm gonna take 2 points. It doesn't matter which two I take, just as long as they are by each other. So I take these two, or these two. I'll take these two just for the fun of it. So I rewrite them out as points. So 3.5, 40.25. Don't worry about the decimals. It'll come out all pretty for you. And then 4 and 46. The trick here is to make sure you label it right and put it in right. Call this my first one, call this my second one. Doesn't matter. I can call that my first and this is my second. Just as long as I do my x, y's right. So these are my 1s. These are my 2s. And then I plug them into this formula right here. So 46 minus 40.25 over my 4 minus my x1, which is 3.5. So that gives me 5.75 over 0.5, which when I divide it, gives me 1.5. 11.5 is your change, is your rate of change here. All right, example 4. What is the direct variation? What is the constant rate of change? Let's say a train going 250 miles, it goes 250 miles in 5 hours. What is its rate of change? So we'll just assume it started somewhere. So in this case, you just do y over x, which would be 250 over 5. So that's miles over hours. So that will give you, this is going 50 miles per hour. All right, and this is our last example. It's on a graph. We're just gonna find the rate of change off of a graph. So if I start at 0, 0, and then I get to the point 3, 200. I have to see that it crosses here too. Sorry, this is pretty bad. All right, you have to find a point where it actually crosses, so 203. And then I can do my formula over there. Call this 1, call this 2, x1, y1, x2, y2. Plug it in, so I get 200 minus 0 over 3 minus 0, which is 200 over 3. And that's a repeating number. So, all right, this has been Comparing Functions. Hope it helps and good luck.